Hey class, Miss Jones here, and we are going to be going over some more information about scale factors and the drawings that result. Now you're already pretty good at scale factors because you watched the last video. But today we're going to be going over some specific examples and what to do in certain situations. So let's start with a fairly straightforward example. Here we have a triangle ABC. And what we are told to do is to use the scale factor to enlarge or reduce the triangle below, this one. Okay, so this should be pretty easy. We have the side lengths, and we're being told that there's a scale factor of 3. Now immediately I know my triangle is going to get bigger because 3 is bigger than 1. It's going to get 3 times bigger. So let's look at each of these side lengths, and we're going to multiply them by 3 so that they get 3 times bigger. Right now, side AB is 5 centimeters. Okay, so I take 5 and I'm going to multiply it by the scale factor. And that's going to give me 15. Now you'll notice that I did show a little bit of work inside this box right here. That's because this is our notes. When we come back to this, we don't just want the answer, we want to know what we did so that we can do it again later, right? All right, so let's do the same thing with BC. Right now, BC is 13 centimeters. So we need to go 13 centimeters times our scale factor of 3. Got my calculator. 13 times 3 is 39. So the new triangle will have a side of 39 centimeters. And last but not least, side CA right now is 12 centimeters times 3 is 36 centimeters. So if we made this triangle 3 times bigger, it would have side lengths of 15, 39, and 36. So this next column is a little bit trickier because they didn't tell us what the scale factor is. I need to figure it out. But that's okay. I have something that tells me how to figure it out. If you'll remember, I'm going to use this spot over here. We have a fraction or a ratio that tells me that the new divided by the original will give me the scale factor. Okay, so now I can use, this is the new side, and AB, that's the old side. Okay, now I could use this one with AB, or I could use this one with CA, and I would get the same answer. They'd be the same scale factor. I like working with 9 because that looks easier. Okay, so let's do this. 9, the new side length of CA, divided by the original, okay, which is 12. Ooh, this is going to be a fraction, I can tell, because the top is smaller than the bottom. So I could leave it as a fraction and reduce my answer. Looks like I can divide by 3 on top and bottom. 9 divided by 3 is 3. 12 divided by 3 is 4. So our scale factor, this new triangle, is going to be 3/4 the size of this one. It's going to get smaller. You might also be thinking, well, I could get a decimal answer. I mean, they did right there. Why can't I use decimals? Well, you can. Let's get our calculator again. And let's go ahead and divide. 9 divided by 12 is 0.75. And that makes sense because 3/4 and 0.75 are the same thing. So you choose which one you like to work with better, decimals or percents. And let's keep going. So the scale factor is 0.75. Now, we need to figure out this middle piece right here. So we're going to take the original side of BC, which was 13, and remember, to find the new side, we multiply it by the scale factor. So I'm multiplying by 0.75. Again, with that decimal, I'm going to use my calculator to help me out to do this quickly. Our new side is going to be 9.75. There, and that makes sense because that's about 3/4 of 13. All right, now what I want you to do is I want you to take a minute and solve this column right here. Remember, to solve for the new sides, you take the original sides and multiply it by the scale factor. And that will give you the new side over here. Now, let's take a look at number 16. What we have triangle PQR below. The original side lengths are multiplied by 2.5. There's my scale factor right there. What are the new side lengths? Now this is the part you haven't seen yet. We have these little quotation marks above Q, P, Q, and R. What that means is they're talking about the new triangle, okay? So if I multiply all of these and make it 2.5 times bigger, these little asterisks are called prime. That is telling us that this is P, the new shape, this is P prime. These little prime symbols are there to help us understand that these signs over here are not the same as the original shape. That's what that little prime means. Now, because that sounds like a vocabulary word, I'm going to put it off to the side here. Okay? P prime is said prime, and it's there to show the difference between the original P and the new shape after it's been changed by the scale factor. Since you're already really good at finding new side lengths, just like we did here, I'll let you finish this one up as well. All right, let's look at rectangle A, B, C, D. Now this one has been enlarged to form triangle ABCD prime. Again, there's that prime symbol that we saw before. Now something on this one that's going to trick people is that this rectangle has been turned sideways. You see that? A was here, and now A prime is over here. Now, a lot of people can get confused when shapes start turning around. You have to be very careful to make sure that your corresponding sides match up. So, before we do this problem, I'm going to take my highlighters and I'm going to highlight corresponding sides. We have AB. Over here we have AB. Okay, there's some yellow. We have BC. Here we have BC prime. We have DC right there. Here's DC prime. And last but not least, here's AD and AD prime. There. Sometimes it's helpful to get your crayons out or your highlighters to make sure that your corresponding sides match up. You wouldn't want to use these two together because they're not corresponding. You want to use these two numbers together. All right, so I'll let you finish the rest of this problem on your own to be checked by your teacher. These two are similar. Okay, we've got some rectangles. Now as you fill in the missing side length for X, what I want you to notice is that these are getting smaller. Number 9, I would like us to cross off because it's part of a topic we will do another day. So instead, I'll give you a problem that looks like this. And it's a very popular test question. Go ahead and draw this on your notes with me. We have a triangle right here. And let's call it triangle A, B, C. Now, oftentimes, because mathematicians are lazy, they'll show 2 triangles, one right inside the other. And this can mess people up. So if you look at this very carefully, you'll see we have a little triangle right here. And we have a big triangle all the way out here. Do you see the 2 triangles? These 2 triangles are similar because they are scale drawings of each other, even though it kind of looks like there's one triangle, little one, on top of the other triangle, big one. So, the tricky part to this is knowing which sides match up to each other. Let's give these 2 points here a name. We've got A, B, C, D, and E. So, what if I told you that side DE was 3 inches and side BC was 15 inches? What I want you to do is tell me the scale factor. Remembering that we need to do the new one over the original. Now this can get some people confused. You're looking at this and you're like, okay, well, Miss Jones gave me 2 corresponding sides. This side is the end of this little triangle. This side is the end of the big triangle. But which one's the new one and which one's the original? Well, normally, when we decide which one's new and original, the original one is on the left because we read in this direction. So unless you're told otherwise, this one gets to be the original and the big one gets to be the new one. Does that help? All right. Now what I want you to notice is that on these notes, I didn't give you the answers. You've got a few of these that hopefully you paused on the way through the video and you finished your answers. But if you didn't, it's time to do that now and then go get your answers checked by your teacher. Have a great day.